Hello, this is our four-way chess for charity app. It's our final project for software engineering. We are group 3. So the objective of our project is to create a four-way chess application. And so this chess application will be for cell phones, and it's going to raise funds for charity via ads, donations, and in-app purchases.
I would like to talk about cost, effort, and pricing estimation. In order for us to try to achieve efficient and effective software project, it is necessary to estimate the size and the cost of our project. Therefore, we decided to use the function point algorithm estimation method in order to help us better predict our estimations. So the algorithm involves breaking systems into smaller components that are easily recognized and evaluated. A function point is a subset of units of measurement. So as we can see, we have the total of the gross function point, which is 411. And we did the calculations for the processing complexity adjustment, which is the multiplication of gross function points and the processing complexity adjustments. So we get a total of 436, as you can see. And for the estimated effort is obtained as 44 person per week. And this, in our team size, since we have 7 of us, so that came up to 7 weeks. This is because we are students and we are working only a few hours per week. So this is the reason why we came up with these numbers.
For our estimated costs, there were many factors that were taken into account. The estimated cost of our hardware products is $3,600. This includes the cost of the game, servers that will require, and also the required server maintenance that goes along with it. We estimate the server to cost about $1,200 for the year, and the server maintenance to cost about $2,400 for the year. The estimated cost of our software products is $1,139. This also includes the cost of development tools, libraries licensed software, and data encryption tools for securing payments made in the app. Since our app is on four-way chess, there are many open source resources available that we can use to implement our game, and therefore this allows the cost to be less than it would. And lastly, the estimated cost of personnel is $50,252. This includes the cost of the employees that will cover the final product, and also the cost of training. For this, we assumed each employee would be paid about $100 an hour, working 10 hours a week for 7 weeks total. And we also added an extra $1,252 to the budget to account for the employee training.
Our project timeline is estimated to last 7 weeks, as Sonia pointed out earlier. This will begin on Monday, December 7th, and end on January 22nd, which is a Friday. We decided to use a timeline similar to a Gantt chart, and so in this you can see it broken down by week, what will be worked on. In week 1, we estimate that we will complete all login functionality, including creating an account, resetting a username, resetting a password. In week 2, we estimate that we'll be able to implement all account stats functionality, including donations, win-loss, and player rank stats. In week 3, you can see that we estimate we will complete all leaderboard functionality, including both the donation and the player rank leaderboards. And then from then on, for the last 5 weeks, you can see it will be implementing the ability to play a game. So actually playing a game, we estimate that it'll take 3 weeks to implement that. After that, we can begin working on searching for a game, which will take 1 week, and forfeiting a game, which will take one week. Beyond that, winning and losing a game, that'll be implemented in the 3 weeks when we're developing, actually just playing the game. And then finally, in the play game functionality, it requires that we update player stats after a game is over. So that will be implemented in the last week. And then finally, the in-app store functionality will be implemented in the final 2 weeks of our project. In week 6, we'll be implementing the ability to play an ad to the user and display all items in the store. And in the last week of our project, we will be implementing the ability to process a purchase.
I would like to discuss the functional requirements of our system. The functional requirements describes what the system should do and the behavior of the system as it relates to the system's functionality. Therefore, the functional requirements of our system includes the following: login access that contains login, create an account, recovers username and password. Leaderboard management is where the users are allowed to select and display the highly ranked players and their information. Profile management is where the user's personal profile information is located. Play match includes all the activities that allows the user to start a match and play the game. And finally, in-game store is where users can make all in-game purchases, which will go towards charity. Users are also able to watch ads for in-game currency.
Non-functional requirements are standards that the app should conform to that aren't necessarily categorized as things that the app should do. On the left, you can see a list of all the different types of non-functional requirements that were needed for this project. And as you can see, there's quite a few of them, so I'm going to go over two key requirements. The first is a dependability requirement. The game server should have greater than 99% uptime. This means that we have less than 7 hours per month to take the servers down to do maintenance, to update them. So we need to make sure to conform to this so that players will always have an uninterrupted experience. The next requirement is a regulatory requirement. All purchases should be deterministic to avoid breaking gambling laws. This one's pretty important because if we had, let's say, a treasure chest in a game and you could purchase that as like a donation and you get one random item, this actually falls under gambling laws and can get you sued in countries like the Netherlands, for instance. So to avoid our company taking a hefty fine, this is a very important standard to adhere to.
Next up is the use case diagram. As you can see, there are 5 key actions. I'll start with logging in. The login action has 3 sub actions in that, which are reset username, reset password, and create a new account. These are all extended from login, as you don't necessarily need these to log in, but they should be included in our app. The next main action is view leaderboards. Within this, there is view a donation leaderboard and view a player rank leaderboard. These actions are included in view leaderboards because they're required. Without those 2 different leaderboards, you would not be able to view anything. Next up in the main actions is view personal stats. Within this included are 2 actions to view win-loss stats and view past donation stats. Again, these are included because for the same reasoning as the view leaderboards action. Without any stats to view, you cannot view personal stats. The next main action is play match. Within this, there are 3 actions on our diagram. Update player elo, which elo is just it's a number used to calculate player rank and use in matchmaking. There's also give post-match rewards and search for match. Again, these are included in play match for the same reasonings. And finally, the last main action is access the in-game store. Extended from this are watch ads and purchase cosmetics. These are the same reasons as logging in. These are bonuses to accessing an in-game store, but they are not actually fundamentally required to access the store.
For our project, we designed and created sequence diagrams for each of our use cases. When we were creating the sequence diagrams, we used a website called sequencediagram.org, which is an online software tool used for creating UML sequence diagrams. In comparison to other UML creation tools, the sequencediagram.org offers a tool that utilizes both text notation scripting and the drag and drop model. Using this tool, we created the 17 sequence diagrams needed for our project, which range from a diagram that models the creation of a username to a diagram that models the transaction purchases in the store. On the slide is an example of one of our sequence diagrams, which models a user playing a chess match on our app by showing the different interactions among the different actors and participants.
This is the class diagram for our project. So our class diagram includes 5 classes for this example. So we have the player, the 4-way chess game, the ELO leaderboard, the donation leaderboard, and the donation class. So the player is basically just there to store all the player information and kind of their interactions with other items. The 4-way chess game is everything associated with that actual 4-way chess game. The ELO leaderboard is a leaderboard to rank all the top players. The donation leaderboard is to rank all the top donations for like the week and of all time, kind of encourage people to donate. And finally, we have the donation class, which is going to handle all the payments and donations for our actual application.
The architectural design that our group decided on was the client-server architecture pattern. We found this design best describes the functionality of our app, as our app has many decoupled services that a server can provide, and therefore makes it crucial to our architectural design. In the design, it can be seen that our application's functionality is organized into 4 services, where each service is delivered from a different server. It also illustrates the clients that connect to our server to use the services. These services include the payment server, which is responsible for all in-game transactions and donations, the messaging server that handles all messages, which will be used when players invite friends to a game or are in a game and want to communicate through the chat box. The matchmaking server, which connects the players with each other for a four-way chess game. And lastly, the chess server, which takes care of the actual gameplay itself, where you would have all the player movements and endgame scenarios that happen in a game of four-way chess.
So this is the user interface mockup. So our main screen would look something like what we have on the left. We have make a donation ELO leaderboard, play game, and then here we have a equal sign, which is basically the main menu button. So whenever we tap it, it opens up this menu where we can access all the other screens, and then the actual game screen will look something like this.
So of course we need a testing plan to make sure that everything in our application works smoothly. So at the base level, we'll be using JUnit and black box testing to test each individual unit in our application. We will also then use JUnit with a separate class as the driver for bottom-up integration testing to make sure everything works well together. And then after we've validated everything on our end, we will handpick some alpha testers to do validation testing. So they will play the game and make sure it works as they expect. And after they're done, we will then have an email lottery to select beta testers for more validation testing with the broader public. And this will also have the purpose of generating hype and publicity for our game. For our example unit test, there is buying an item from the store. There are 3 types of items to consider: finite items, which have a certain quantity that you can buy; infinite items, which you can buy as many as you want of; and invalid items which shouldn't even appear in the store. And we made sure all of them behaved as intended, updating the user's balance, the user's inventory, and the store's stock, or not updating the store stock in infinite item case. And we also made sure that the invalid items were not added to the store at all. And the results, all of these tests successfully passed, and the unit test even caught an error where infinite items were not being added to the store. They were being mistook as invalid items.
Here is the software process model. Prototyping cannot become the natural choice after our first 2 meetings. Compared to waterfall process model, prototyping carries some easy advantage, such as it's more flexible to manage our competition goals step by step. On the first meeting, we only have a core idea of how to play the full chess game, and the purpose of collecting charity donations. But after that, we have to come up a basic construction of the application. So after the first beginning meetings, we come up with some basic functions like how to log in access your account, how to build the user profile. But after that, we come over again. We have another version with more functions, advantage features such as the actual game playing, the ELO system, and the game stores to build a complete system. The main reason we are choosing prototyping as our software process model is more ideas can come with the prototyping, and less bugs could be developed during this whole system.
Also conducted a comparative analysis of our software application, 4-way chess for charity, in comparison with similar designs in our field of our project domain. After extensive research, we noticed that there was a major difference between our application and others was the motivational factor, which is the driving force that motivates users to perform the tasks needed to donate to charity. For example, for applications like Impact and Charity Miles, the motivational factor is self-improvement. For these apps, the applications are trying to encourage charity donations with the health benefits of regular exercise. In the case of applications like Free Rice, the user is incentivized with trivial pursuits as a way to help hungry families around the world. In comparison, when it comes to our application, we are heavily reliant on the novelty of 4-way chess, which, although is a risky move in the current market, the novelty of our application can help us in maintaining a consistent and active player base.
For conclusion, overall, we as a group have accomplished the most project goals and construct a workable plan for building up this 4-way chess game and for charity purpose. Every member have fulfilled their personal task perfectly. If there one thing might need to change or getting better, I would say it's charity is not an easy task. We have to have more connection with some charity organization to make our donation actually using on the good purpose. Basically, that's all our project. Thank you for listening.